Hello everyone, my name is HC and I prepare for that certificate. If you don't know Tensorflow, it's a library for machine learning, deep learning. Although more and more people use PyTorch, but for the basics, I think that it's much easier to get into. So here is the certificate to checklist in it, and it's time to build some model. So I did some background research, some Google search, and these are the tasks I think I'm going to work with during the exam, so I just go through them. So let's start. Now use TensorFlow. As you can see, it's 2.6. That's the first tick. There we go. Let's build, comply, and train a machine learning model using TensorFlow. So reprocess data to get ready for use models to predict results with sequential models with multiple layers. So I need a database for machine learning and deep learning, so let's use a good old dataset. I just copy this, but before that oops, there we go. So what I'm doing here with this line of code, I actually save a bit of typing. I don't have to retype this df.keras again and again and again. Quite useful. What is happening here? I have this Boston housing dataset, and it turns into a training dataset and a test set. 20% for the test and the random seed, of course. Here you can see the dataset. But before that, let's random since. So if someone runs this code, he gets the same result as me. Okay, there we go. Now, actually should save this. There we go. Now let's do some check with the data. Xtrain is my label. Ytrain is my actually quite the opposite. So Xtrain is my list of features, and Ytrain is are my labels. So let's check. I have the same number of them, so that's a good start. Let's import another tool of mine. Check it. So what I have here, this is the average, max values, min values, quite widespread, and of course the good or standard deviation. Now that's a simple small dataset, so I don't really want to dive into it, but you can check the features here, and normally you want to really check your data, but in this case I know that it's more or less good as it is. Let's create a model, a simple sequential one. Let's use some nice activation function with for the hidden layer. Same thing. Okay, let's use another. That's the output layer. That's the default, by the way. So I have here a very simple, very basic model. Now I'm quite sure that it won't work because I don't have any kind of regulations. So let's use dropout. Actually, I should save the model. Let's use a loss function. Mean squared error is fine here. Let's first try loss optimizer. them as a first try. Let's use metrics. In this case, it's the same as the loss function. Almost. And let's feed I want to train it on the training data. I want to train it for, I don't know, 500 epochs. That's one epoch is a one learning cycle, kind of. Let's use the validation data. That's the extreme X test, Y test. So essentially what is happening is you train your model on this subset of your original dataset and you test it on this. Because if it happens that you train and test on the same dataset, the model can memorize the whole thing just as it is and it won't work. I could use some fancy things like learning rate adjustment. Why not? I mean, it's called a callback. Just I can never actually remember the name of it. Yeah, there we go. Let's go to the example. I only did this part because I'm lazy. Now, what I want to work with the validation loss. That's basically this. I want to decrease the learning rate. Actually, I want to multiply it with this value. If for this many learning steps, epochs, the model doesn't learn anything new, so the validation loss doesn't go down. So from a few experiments, I know that I should do something like this because this is actually the minimal value, default value of the model, so it doesn't make sense if I don't decrease it at all. So let's do this. Let's change it to this. So let's do something like this. So for 200, the model learns for 200 epochs, then probably drops. It trains for another 200 and drops again. And if you multiply this number basically in 2 steps it drops the learning rate to the 1/10 of the original. What is nice because the original one was 1 to 1000 and this is 1 to 10,000. So let's actually run this code. What is your problem? Yeah, and in this part, there we go, it works. I wanted to say that I want to train, but yeah, comma is of course missing. What else? Position for the this is a quite common error actually, but I'm kind of curious what it means because I'm I have no clue. I completely forgot about it. Okay, no thank you. Mm, so it's the order of this. Oh, okay. No. Okay. Let's check it out. So it comes. What is the calculated goals here? What is going on? Oh, there we go. Let's check the validation error. You can see that at this point it doesn't really change. It, you can see that it is jumpy a little bit, so it goes 21, 16, and so on sometimes. So let's get a little bit fancy here. So let's see the best of these. I have a nice little cheat sheet, kind of. What do I need actually? I need a checkpoint. That's on the complex. Let's set it up. That is good. Save the weights only. Yeah, I don't need the raw model. Save the best one. Yes. Save yes, save every epoch. Actually, check every epoch. Yeah, I don't want to see even more text. And let's create a checkpoint because we, paste here. Let's actually use the best weights. And let's do some tests here. As you can see, the last was this, but we have much nicer values. That's because it found the only one. Now you could play with this. I think that this is just enough for a simple regression model. Now, oops. Let's use it to predict something because we have a model to predict stuff. Nice one, nice. Let's use the first label. Actually, let's use the last one. My bad. Some stupid error. Okay, my bad. So in this case, I actually use the first one. Here's my prediction. Let's check the label. The first one. Oh, yeah. As you can see, it is a little bit off, but it is what it is. Now, normally I would go for visualization. So, actually, let's use some code from here. Now the question is, does this let's try it out. But I have a feeling that it doesn't do the... Okay, let's do the... What is your problem? Exterior is not defined. But that's a function. Why is it? So this is do these many ways. But not this way. Anyway, if this fails, I know that it doesn't work. So it is as it is. I'm again lazy. Shouldn't be, but I am. Let's do this. I need to import another nice tool for the visualization. Actually, what I'm doing here is I want to show you the training data, the test data, and the predictions. Something went wrong because that's a I must have the same. Okay, let's put the three data trainings. That should be correct. Test data statements and the test data against the predictions. Let's comment this part out. Yeah. If it doesn't work, trees after all. Shape 102. Let's use something like data frame. Maybe it works this way. Okay. So I have a numpy. What is the type of this built-in function? Okay. I should probably just do this the best way, but still the same. Access. What is wrong here? Something is wrong. Oh, silly me. So I have multiple feature columns and this would only work with one feature column. So yeah, I can't really do a visualization here. I mean, I can do something like okay. simple. What if I do something? So I have a plot of the samples, the labels, and the thing is that based on these values, I know more or less that I could try other configurations and it wouldn't be much better. But anyway, I want to figure it out. So here is the original notebook I use for learning. It's a very nice course, by the way. And actually, I use the same dataset like here. Different. I use a different optimizer. Yeah, you can see that it's just one simple feature vector column. I actually don't know how it's called. Anyway, if you know, hit me up with the answer. So there we go. I can just use it as it is. Okay, let's go again. What is different compared to mine? So he has this prediction. I also have this prediction. Model 1 dot predict X test. And I don't want to squeeze it now. Let's go this way. You can see this is what disappears if I use squeeze. It's an umpire array in this case. And now it works. Interesting. That's very interesting. I thought that I need to remove the outermost. Yeah, experience, huh? Okay. Anyway, you can see that how the test and the ground truth labels compare to the actual values. As you can see, there are some significant errors here and there, but mostly it's mostly. It can mean that I need more layers, more cells, like this, or I don't have enough data, most probably for this, because I only had 400 examples, so that's more for a machine learning model, not for a deep learning model. So I will say that it is enough for a simple model. Actually, I could even use it for almost a complex model with DNN, because DNN means dense neural network. Now let's see what I did. Build, comply, and train model. Yeah. Build, comply, train. Preprocess the data to get ready for using the model. Yeah, next time use the models to predict results. Done. Build sequential models with multiple layers. Done. That's more than one. Build and train models for binary classification and multi-class categorization. Now, the thing is that you do almost the same for all of these DNN networks. So what changes is the activation function. So for binary you need binary classification, you need sigmoid. For the multi-class, you need softmax, and also the shape of the output layer changes. For the binary, it's the same as 1. For the multi-class, you need for 3 categories, you need 3. For 5, you need 5, and that's all. Of course, the loss function, the optimizer, and the metrics change with the type of the problem, but I would say that, yeah, I know this. Plot loss and accuracy of a train model. I could actually there you can see here the learning rate. You see that you don't see anything. The loss, the mean squared error. You can see that the validation mean squared error quite jumpy. We can verify this here with these values. I could maybe use SGD or some other optimizer, more complex models, but I think that's it. More data. These are the main lines, main ways to improve your results. Okay, that's it for the simple model, and see you guys later.